Hello, sir. Today we want to explain the reconfiguration GA program optimization. As you see here, this is the file for reconfiguration GA, and after that we will explain all things, but the common file we will explain quickly. The reconfiguration here to optimize the reconfiguration using GA for the IEEE 86 bus, and how the implement the genetic algorithms. The first file is the main file. The main file is to implement the genetic algorithm optimization for the reconfiguration, the optimal reconfiguration for 86 bus network. The first line is to clear and CLC the command window and workspace, and after that we defined the number of variables, of decision variables. As you know, there is 5 line we want to reconfiguration, and after that we define the lower band the line, and upper band the line, the number. So the first reconfiguration line from we have 19 line we can reconfiguration, and the same thing the second is 11 and 14, the third line 20, 30, and after that we define the fitness function is the load flow with the x is the variables. This is the variables that want the program to optimize for the x, and for this is the fitness function defined to put it in the genetic algorithms program. So if you open the load flow, the x is the variable that want to optimize to get the best fitness function. And then after that we defined some parameters for the GA. The first thing is the lower band and upper band for variables, decision variables. The object function is the fitness function, the number of variables, the maximum generation 100. This is the maximum iteration, means that. And after that we also defined the number of chromosomes. It's the number of particles, mean. And then this is the data, as you see, genetic data. Applied the inputs that defined on the genetic algorithm, and after that we get the best solution from the genetic algorithms. This is the best solution is the number of line, which line want to open, and after that this is the best solution. Applied the line configuration, and after that the load flow to print and get it the result. So the load flow is to get the result, and the line configuration to make the constraint on the best solution. And after that we get some the variables and printed the result, the power loss, reactive power loss, and after reconfiguration, and after the optimal open line. This is the main program. The next video we will explain another files, so we hope understand that. Okay, this is the second video for explanation the GA reconfiguration. We want to explain GA program, genetic algorithms. This is the genetic algorithm optimization, and this is dependent on the lower and upper band of search space, and dependent on the number of generation, size of population, mitigation, additional crossover, initialization population, and so on. The first thing is if the number of generation is equal, number of generation parameter or variable is equal one, so the G equal genetic algorithm data. Else the error is printed. And after that, this is if the parameter does not exist in the data structure, it is created with the default value for the GA. So if you don't define the number of variables or maximum generation or number of population, the alpha or PM object parameter function, so the program will define the default variable for that parameters or variables for all that. And after that, we put command warning off to see how the program converge, because if this not command is not existing, so the genetic algorithm will make some warning and print it in the command window, and we don't see how the program converge in each iteration. So this is to warning off. The warning is not printed on the command window. And after that, internal parameter defined, as you see here in the genetic data structure. This is the chromosome, the object variables, the x minimum, the fx minimum is defined in infinities, and the x minimum generation, fx minimum generation, and the generation 0 and ref. We will explain each one in the place. The main loop is the start, and the generation is counter is 0 to repeat the maximum number of generation, and after that initial population. In this function create that we will initial population, the chromosome will be generation for the GA, depend on the GA data, the number of chromosomes, the maximum and minimum lower band and upper band. And after that, the individual of GA are randomly added to the initial population. Then we will make some tested if this is the genetic data in DNA is empty, so the ND0 is equal the size of ND, and the precision random parameter dependent on the number the NED0, and after that the chromosomes will be dependent on the this parameter NDINE. And then the starting loop is begin, and as you see here, the generation is equal the data generation, and the data data equal GA evacuation, dependent on the GA data, and increase the generation counter, and store the minimum, the x minimum, that the population, and this is the value of fitness function, the minimum. This is mean that the best position, and the value of the best position of the fitness function. And after that, we increase the generation counter, and put it in the best cost the value of minimum fitness functions. And this is repeated until the maximum generation is finished, and then the main loop is ended. And after that, we present the final result by the function of GA result, the GA data, and plotted the conversion factor of the best function for each iteration. And this is the function of GA is finished. In the next video, we will explain the sub-function in the GA. Thank you very much. Hello, sir. This is the GA function, sub-function explanation. The first one is the chromosome, crypt random function. There is two input and one output. The output is the chromosome, that the population, and the input is two things: the number of population, and the maximum and minimum, maximum and minimum upper and lower band. This function is to generate the random real value matrix, is created by upper and lower band. So this is the randomly dependent on the number of variables. As you see here, we can the chromosome is generated randomly dependent on the upper lower band, multiply the random plus the lower band. So this is to generate the initial population. This is file or sub-function to generate the initial population randomly. And after that, there is another sub-function is GA evaluation for GA data. One generation. This is to evaluate the fitness function, and to get the best solution. So the chromosome is equal to the GA data chromosome. It's as input, and we will get the output from the GA data structure. The chromosome is equal the GA data chromosome that may be generated randomly, or using the genetic algorithm to generate. And after that, the defined some parameters: the number of populations in the chromosomes, and the number of objective values. And then, as you see here, to evaluate the value of the fitness function by institute the chromosome and the object function, and get it the object values. And after that, store the object value on the GA data object value. And after that, we will compare between the best individual of the each generation to get it the V and P, dependent on the minimum object values. If this value, the minimum, is less than the best one, so we will store the new chromosome in the X minimum, and the value of fitness function of that chromosome in the F minimum, and this is repeated for the all generation until to get the best one. And after that, the optional additional task required by the GA iteration function, as you see here, this is the function. Input the GA data, and this is the GA to printed the result, the best result in each iteration. So in each iteration, this function will printed the result, and after that we will ranking the object function for ranking using the ranking function. This is the subject ranking function to ranking the fitness values, and after that we will make selection stochastic universal sampling dependent on the chromosome and dependent on the fitness values, and then to crossover dependent on also the genetic data, the selection chromosomes, and the alpha parameter, PC parameter, and after that the mutation to get the new chromosomes. This is the new chromosome dependent on the selection chromosomes and dependent on the upper band and lower band, and then reinsert the best individual chromosome in the G-data chromosome, GA data chromosomes. So this is the genetic algorithms process, how to use. This is operational. After that, this is to generate the next generation, and this is the process of GA, to ranking, selection, crossover, mutation, and reinsert the best individual. This is to generate a new generation, and this is the new generation or a new chromosome. We will use it in the next generation or the next iteration to calculate the value of the fitness function, and so on, after to finish the maximum generation. And every iteration we will compare the new chromosome with the old best one, and if the new chromosome is best than or less than the best one, so we will update the minimum values and the best chromosome, and so on. This is the GA function. We hope understand us that the next video we will explain the other files about the GA reconfiguration. Thank you very much. Hello sir, this is the fourth video to explain the load flow, the fitness function, but the fitness function is the same that the fitness function is the same, the PSO reconfiguration, so that we have a quick explanation. And in this file, or the fitness function, we have the fitness value is the output, and the input is the number of line want to open it. The difference between the PSO and GA, we included the line configuration in GA in the load flow function, because the GA different than PSO program, because we use the line configuration or the constraint of the line configuration in the BSO program, and after that apply it on the load flow. So this is the only difference. So because the GA program is a closed loop or a closed program, we cannot put it many things in that program. So we put it this in the load flow program is easy for us. And after that, the line configuration is as you see here, the X is the number of line want to open it, dependent on the each line, the number of the line, as you see here, as you know. The line 1 we have 19 choice, and the second line is 11 choice, and so on, like this, because the line 1 is 19, 11, 14 the line 4, and after that this is round to be integer, and apply the line configuration functions to see which the line should be open. And as you know, this is the line configuration. The line configuration, we have the open line, the number of open line, depending on the switch 1, 2, 3, 4, 5. So the depending on the open line, we select the number of line should be opened, and after that is stored in the L, and this is L as output, and after that we check if this configuration is applicable or not applicable, as we explained before, and after that we have two output. The first output is the line configuration, and the second is the factor is applicable or not applicable. If the factor is equal 0, so the load flow we can implement it. If not, this is the load flow is not implemented, so the fitness function is equal 10,000, and so on. And if the reconfiguration is applicable, the load flow is started, and read the load path, and the number of bus, number of branches, and the base voltage, base MVA, and per unit values for the resistance and reactance, and the power in each reactive and real power for each buses. And after that, with the load flow is starting to arrange the buses in the routes, which are the routes, and until this, to arrange that, and after arrange the radial route, we will start to calculate the voltage and current values. The first thing is to suppose the voltage is equal 1, and after that we calculated the current in the branch current, and after that we calculated the accumulated branch current dependent on the each route. So accumulated branching current, and after accumulated the branching current, we recalculate the voltage at each buses dependent on the voltage drop on the line in each branches, and accumulated the branches current, and repeat the process 10 times, and then we printed or calculated the voltage buses, the current at each branches, and then we calculated the power loss and reactive power loss, and accumulated power loss and reactive accumulated reactive power loss, and put it this power loss in the fitness function, as you see, the sum of the power loss and the sum of the reactive power, and we also calculated the voltage deviation that included in fitness function, if this reconfiguration is applicable. If not, the fitness function, as you mentioned before, is 10,000. This is the load flow and the line configurations. A quick explanation because it is the same, the PSO program. Thank you for your listening. In the next video, we finished the explanation of other file. Okay, this is the last video for explanation the file. This is the line data for 86 bus. As you see here, this is each line that want to be reconfiguration and optimal reconfiguration. We put it all the lines and the program select which the line is open. And the load bus also, this is each bus for the real and reactive power in each buses. And the power, this is the power losses for the base load flow without reconfiguration, and this is the voltage bus at each bus for case of without reconfigurations, and this is used in the printed results. This is the all files explanation, and the load flow, as you mentioned also before, is the same, the load flow process, but in this load flow to printed some result, make the load flow for the best solution, and after that we figured the voltages with the configuration, without configuration, the power loss with configuration, without configuration, that named base case. This is all the files we want to explain. In the next video we will explain the result. Thank you very much.